In 1946, Hungarian mathematician Paul Erdős posed a discrete geometry problem that would stump the world's brightest minds for 80 years. It's known as the planar unit distance conjecture. Recently, an artificial intelligence solved it. The puzzle is deceptively simple. If you scatter a set number of dots on a flat surface, what is the maximum number of pairs that can be exactly 1 unit apart? For decades, mathematicians believed the answer was capped by arranging the dots in square, grid-like patterns. The reasoning model solved the problem by moving past standard two-dimensional geometry. It synthesized deep algebraic number theory to find a denser, far more efficient arrangement of points using hidden numerical structures, a shortcut humans hadn't conceived in nearly 8 decades of work. This wasn't a computational fluke. The proof was formally reviewed by external mathematicians and verified using Lean, a rigorous proof assistance system used to certify the world's most complex mathematical logic. However, this reasoning capacity is currently too computationally heavy to function as a real-time feature for the millions of people using ChatGPT. For now, the breakthrough is siloed by the physical limits of the hardware required to run it. Deep heuristic reasoning requires massive, sustained compute cycles. At the current scale of AI adoption, the inference latency and electricity costs of letting the model think through complex problems make it commercially impractical for a standard user interface. To solve this, OpenAI and Microsoft planned a $500 billion infrastructure project called Stargate. It was designed to be a gigawatt-scale data center capable of powering these frontier models, but the project has run into a wall. The physical world has proven difficult to scale. Protracted hardware supply chain bottlenecks and severe weather in Texas recently stalled construction at a key data center campus, exposing the fragility of building at this magnitude. The intelligence of the software has effectively outpaced the physical world's capacity to build the data centers and power grids necessary to support it. Facing a compute shortage, OpenAI secured a $50 billion multi-cloud agreement with Amazon. The deal grants OpenAI access to 2 gigawatts of capacity, powered by Amazon's custom Trainium chips. Microsoft immediately threatened legal action. They cited a breach of their exclusive Azure cloud agreement, signaling a major fracture in the industry's most important partnership. To avoid a pre-IPO lawsuit, both sides renegotiated. Microsoft dropped its cloud exclusivity and royalty requirements in exchange for a 27% equity stake, leaving OpenAI to navigate a fragmented multi-cloud environment. To fund these massive infrastructure costs, OpenAI launched the Deployment Company. It embeds forward-deployed engineers directly into Fortune 500 headquarters to build custom AI systems on-site, capturing implementation fees and securing massive enterprise contracts. OpenAI now operates as a vertically integrated enterprise service provider, locked in an expensive, high-stakes fight for the computational resources required to keep its models running. This frantic corporate acceleration has created a shadow. Security audits have revealed catastrophic blind spots within the AI's core execution environments. Researchers discovered a ChatGPT flaw where a malicious prompt bypasses guardrails, tunneling sensitive data outward through hidden DNS requests without triggering warnings. Another codex vulnerability let attackers break out of the secure sandbox, smuggling commands to steal secure GitHub tokens from the repository. Crucially, the models assumed their environments were safely isolated. Because of this, the AI failed to recognize or stop the data theft as it happened. The reasoning architecture that can overturn 80-year-old mathematical constants is being deployed on infrastructure that currently fails to stop basic data exfiltration and sparks multi-billion-dollar legal warfare. The current race is a desperate attempt to engineer a physical, corporate, and security cage strong enough to contain the intelligence that has already broken out of the lab.